Welcome to Lunch Break Wisdom, short ideas from the world's most influential books, designed for a quiet break between work, a commute home, or a moment to think more clearly. Today's episode explores one of the most famous science books ever written, A Brief History of Time by Stephen Hawking. Unlike many scientific texts aimed solely at specialists, Hawking attempted something extraordinary. He sought to explain the biggest questions in existence to ordinary people. Questions that philosophers, astronomers, theologians, and curious minds have wrestled with for thousands of years. Questions such as, where did the universe come from? Did time have a beginning? What are black holes? Can we understand everything through a single theory? And perhaps the most profound question of all, why does anything exist at all? Hawking begins by reminding readers that humanity's understanding of the cosmos has evolved dramatically. Ancient civilizations often imagined Earth at the center of existence. The sun, moon, and stars appeared to revolve around us. The universe felt intimate and human-scaled. Then came figures such as Nicholas Copernicus, Galileo Galilei, and Isaac Newton, who challenged prevailing assumptions. Humanity gradually recognized that Earth orbits the sun. The sun itself occupies no particularly special position within the galaxy. Our galaxy represents only one among billions. This realization can feel unsettling, yet it can also inspire awe. The universe is vastly larger than everyday experience suggests. One of the book's central themes concerns scientific humility. Throughout history, people repeatedly believed they had reached the limits of understanding. Again and again, new discoveries expanded horizons. The lesson is powerful. Certainty deserves caution. Curiosity remains essential. The universe consistently proves stranger and more fascinating than previously imagined. Another major topic involves time itself. Most people experience time as obvious. Yesterday preceded today, today precedes tomorrow. Time appears to flow in a single direction. Yet physics complicates this intuition. According to Albert Einstein's theory of relativity, time does not function identically everywhere. Time can slow under certain conditions. Velocity influences temporal experience. Gravity affects the passage of time. This sounds like science fiction, yet it has practical implications. Even technology such as GPS require adjustments accounting for relativistic effects. The universe challenges common sense. Another profound concept explored by Hawking involves the Big Bang. Current scientific evidence suggests that the observable universe expanded from an extraordinarily hot and dense state approximately 13.8 billion years ago. Importantly, the Big Bang does not describe an explosion occurring within space. Rather, it represents the expansion of space itself. The implications are astonishing. Everything currently observed, galaxies, stars, planets, human beings, all emerged from conditions present near the universe's beginning. In a very real sense, every person shares cosmic ancestry. The calcium in bones, the iron in blood, the oxygen sustaining life, these elements originated within stars. As astronomer Carl Sagan famously observed, we are made of star stuff. Hawking also explores one of the universe's most mysterious phenomena, black holes. Popular culture often portrays black holes as cosmic vacuum cleaners, consuming everything indiscriminately. The reality proves even more fascinating. Black holes emerge when massive stars collapse under their own gravity. Their gravitational pull becomes so intense that not even light can escape beyond a boundary known as the event horizon. For decades, scientists assumed black holes destroyed information entirely. Hawking challenged aspects of this understanding. He proposed that black holes emit subtle radiation, now known as Hawking radiation. This idea revolutionized theoretical physics. It suggested that black holes may eventually evaporate over unimaginable timescales. The broader lesson extends beyond astrophysics. Reality frequently defies intuition. Remaining open to revising assumptions constitutes intellectual strength rather than weakness. Another recurring theme involves the search for unification. Physics currently describes nature through multiple frameworks. Quantum mechanics explains subatomic behavior. General relativity explains gravity and large-scale structures. Yet these theories remain difficult to reconcile completely. Hawking expressed hope that humanity might eventually discover a unified theory encompassing all fundamental forces. This aspiration reflects something deeply human. People seek coherence, patterns, understanding. Whether through science, philosophy, or spirituality, individuals attempt to make sense of existence. The journey itself often proves meaningful. The book also addresses uncertainty. At quantum scales, probability replaces classical predictability. Particles behave in ways challenging ordinary expectations. Certainty diminishes. This realization can feel uncomfortable. Human beings crave predictability. Yet uncertainty characterizes much of existence. Relationships involve vulnerability. Careers evolve unpredictably. Health fluctuates. Learning to navigate uncertainty gracefully becomes increasingly important. Another beautiful aspect of Hawking's work involves wonder. Science is sometimes portrayed as cold reductionism, yet Hawking repeatedly communicates awe, the elegance of mathematical laws, the vastness of cosmic structures, the possibility that conscious beings emerged capable of contemplating the universe itself. Wonder enriches life. People often lose sensitivity to everyday miracles. Sunsets, music, human connection, scientific understanding need not diminish wonder. It can deepen it. The book also explores human significance. Some individuals interpret humanity's small physical scale as evidence of insignificance. Hawking suggests another perspective. Although occupying a tiny fraction of the cosmos, human beings possess extraordinary capacities: curiosity, creativity, self-awareness, the ability to investigate reality. Perhaps significance emerges not through size, but through consciousness. The fact that the universe has produced creatures capable of reflecting upon its existence remains extraordinary. Another important lesson concerns the value of questions. Science advances through inquiry. People ask, what causes this phenomenon? How does this system operate? Could alternative explanations exist? These habits of mind extend beyond laboratories. Curiosity strengthens relationships, improves leadership, enhances decision-making. Good questions often matter more than immediate answers. Toward the end of the book, Hawking reflects upon one of humanity's oldest aspirations: understanding everything. He recognized that complete knowledge may remain elusive. Yet he celebrated the pursuit itself. Progress occurs incrementally. Each generation contributes pieces. Humility accompanies discovery. Ultimately, a brief history of time remains influential because it democratizes wonder. It reminds readers that cosmology does not belong exclusively to scientists. Questions concerning existence belong to everyone. Where did we come from? How did the universe begin? What laws govern reality? What remains unknown? Perhaps the greatest lesson is this: the universe is both comprehensible and mysterious. People may never answer every question, Yet the desire to understand reflects something profoundly human. Curiosity expands horizons. Humility tempers certainty. Wonder enriches existence, and perhaps meaning emerges not solely through possessing definitive answers, but through participating wholeheartedly in the ongoing adventure of discovery. Because on a small planet orbiting an ordinary star, conscious beings have learned to gaze upward and ask questions, reaching across billions of years and unimaginable distances. And in doing so, humanity has revealed one of its most beautiful qualities: the refusal to stop wondering. In summary, key concepts from the brief history of time. 1. Scientific humility, understanding, evolves continuously. 2. Time is complex. Relativity challenges everyday intuition. 3. The Big Bang. The universe expanded from an extremely dense early state. 4. Black holes. Gravity creates some of nature's most extraordinary phenomena. 5. The search for unity. Scientists seek coherent explanations of reality. 6. Wonder enhances life. Knowledge can deepen awe. 7. Curiosity defines humanity. Questions drive progress. Everyday takeaways for you. Remain open to revising assumptions. Embrace curiosity across disciplines. Recognize that uncertainty accompanies growth. Cultivate wonder alongside knowledge. Appreciate humanity's remarkable capacity for inquiry. Ask better questions rather than rushing toward conclusions. What question about the universe fascinates you most? Black holes, time travel, the origins of existence? Share your curiosity below and suggest future books for lunch break wisdom. Please subscribe and comment.